Hey guys, today we're working with patterns and sequences. This is lesson 8. Patterns are just math puzzles. We're going to learn how to look for cues to determine mathematical rules and to make predictions. This lesson is critical to your future math studies, so be ready to take notes, engage with the material, and ask questions. We've got 3 learning objectives. First, we're going to learn how to identify patterns in numerical sequences. Second, we're going to determine if a sequence represents a function. And finally, we'll use tables to determine if a function is linear. We've got 3 words that we need to know. First is patterns. A pattern is anything that repeats in a predictable way. Sequences, well, a sequence is a list of numbers that follows a pattern. So a sequence is always a pattern, but a pattern is not always a sequence. And finally, term. Each number in a sequence is called a term. Let's explore these concepts a little bit further. So patterns, there are a couple of ways to talk about patterns. First one is arithmetic or arithmetic patterns. Arithmetic patterns, these are numbers that increase or decrease by a constant amount. What we're talking about here is increasing or decreasing through addition or subtraction. So if you use addition or subtraction to move from one number to the next, it's an arithmetic pattern. A geometric pattern, it's numbers that are increased or decreased through multiplication or division by a constant amount. So if you move from one number to the next through multiplication or division, it's a geometric pattern. And then there's lots of other patterns based on squares, which you'll see later on in this course when we move on to quadratics. In Algebra 2, you'll learn about cubes. And then when you take trig, calculus, there's even more complex patterns with more complex rules. Here's our first pattern. Let's think about what should come next. Well, we've got 4 rectangles. Let's look about what's important here. Here we've got a shaded corner. Here's another shaded corner. And here's another shaded corner. And this 4th box, we've got yet one more shaded corner. Take a moment and think about this. And by the way, this is taken from your independent practice work. So if you want to pause the video, print it, or you can use your note-taking pages. And this is in your note-taking pages. Either way, pause the video and I'll be waiting for you on the next slide so you can let me know what you think comes next. Here's what comes next. Our 5th rectangle, and we got what? 1, 2, 3, 4, 5 rectangles. Our 5th rectangle looks just like the first. Sometimes in courses like this, you're asked to explain what happens, explain the patterns using words that aren't overcomplicated. What you could say is the darkened shape moves around the rectangle clockwise, so the last rectangle is just like the first. Since there's no numbers here and we're dealing with shapes, this is a pattern. Let's look at one more pattern. Here's another pattern. We've got rectangles with other rectangles in them. What do you think should come next? Pause the video, think about it. Once again, I'll be on the next slide waiting for you with the correct answer. What I noticed about this, here I had 1 rectangle, here I had 2. I noticed 1 plus 1 is 2. Here we had 3, so 2 plus 1 is 3. And finally, 4 rectangles. 1, 2, 3, 4. If we add another box, we would have 5 rectangles. 1, 2, 3, 4, 5. And this goes on for infinity. You can keep adding squares and rectangles as long as you want to. You can spend the rest of your life doing that. One more pattern. There's another one. what shape should go in box number 4 here? We've got 1, 2, 3. So what should go here? Think about it. Pause the video. Once again, I'll be waiting for you on the next slide to tell you what I think should go in box 4. Did you get the same thing for your box 4? How I work this problem is I notice there's 1, 2, 3, 4 sides here. Then I notice there's 1, 2, 3, 4, 5, 6. 6 sides. So 4 plus 2 was 6. And then here we had 1, 2, 3, 4, 5, 6, 7, 8. Well, 6 plus 2 is 8. So on my box 4, I came up with a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10-sided figure because 8 plus 2 is 10. Then how many sides do you think this last extra shape has? This would be shape number 5. If you said 12, you're correct because 10 plus 2 is 12. And then if we had box number 6, how many sides would this one have? Well, 12 plus 2 is 14, so that should have 14 sides. Now, here's a new pattern. What do we notice about this pattern? That's correct. It's got numbers. Remember, a pattern with numbers is called a sequence. So study the sequence and figure out what's happening from one number to the next. Using this information, determine what should go in the empty box. Pause the video, and I'll be waiting for you on the next slide with an explanation. Figure it out? Did you figure out what's going on between these numbers here? So from 9 to 19, well, that increases by 10. And the only way to get 9 to turn into 19 is to add 10 because, well, 19 is a prime number. But let's add 10 to 19 and see what we get. Oh, we get 29. And then let's add 10 to 29 and we get 39. So our pattern here is plus 10, and we could keep adding 10 forever. And we're not going to do that because we got a lot more fun stuff to look at here. So what comes next on this pattern? This one looks a little bit different. What I noticed difference is we got variables, right? We got an n plus 2, an n plus 4, and an n plus 6. Don't worry, it's going to work just like the previous examples. Just look how the numbers are changing. Pause the video, and I'll be waiting for you once again on the next slide with what I think's happening. Well, what I noticed on the previous slide is each of these had just an n, and then they all had a constant. And I noticed the constant was the first time I added 2, and then I also multiplied by 2. Well, 2 plus 2 is 4. 2 times 2 is 4. And then to get from 4 to 6, I did plus 2. Well, that checked out. When you do 4 times 2, well, that's 8, so that doesn't check out. So now I'm really thinking, is my pattern plus 2? And it is. So I add 2 to get 2 to 6 to get 8. So it's n plus 8. Next one would be n plus 10, n plus 12, so on and so forth, on to infinity. Or as Buzz Lightyear would say, infinity and beyond. So just remember, a sequence is a pattern, but a pattern may not be a sequence. A sequence has numbers, and a pattern can be anything that repeats. And on your quiz, there's going to be a question about this. It's going to say, Can a sequence be a pattern? Or what's the difference between a sequence and a pattern? Either way, I'm not really sure about the phrasing of the question because I don't want to give too much away, but do remember, a sequence is a pattern, but a pattern may not be a sequence. Other thing that you want to know is this is your first term, your second term, third term, fourth term. These dots means it goes on forever, it's infinite. But it's important to know first term, second term, third term, fourth term. Moving on. The reason that's important is because we're going to put some numbers in the table. So here, this is x1, which is your first term. This would be x2, your second term. This would be x3, your third term. This is x4, your fourth term. A table that's like this one right here, we just wrote in, that's a horizontal table. We call it a horizontal table because it lies across the horizon. And just like we have x1, x2, y3, y4, we do the same thing with y. y1, y2, y3, y4. And over here, x1, y1, x2, y2, x3, y3, x4, y4. Tables are huge in algebra. We also use them a lot in spreadsheets. So by getting good with tables in algebra, if you ever decide to hone your spreadsheet skills, you'll be a lot better spreadsheet operator. Just remember, in both types of tables, it's important to list the x values in ascending order. And ascending just means you start with the smallest x value. Whatever y goes to that smallest x value goes in the x1, y1 position, so on and so forth. We'll look at some examples. So let's go ahead and place these dots, and we're going to place them both in the horizontal table and the vertical table. So we're going to place the ordered pairs with the smallest x in the first space. Next, we're going to replace the remaining relations in the tables in ascending order. So you may want to pause the video, kind of work it out yourself before you hear me explain it, because by pausing the video and working it out yourself, you're really activating your mathematical thinking skills. Also remember, we use tables to make it easier to analyze patterns and determine if points lie on the straight line. So our first point, -4, -5, well, that's in our x1, y1 spot. So we call this x1, y1. Now you look for x2, y2. Well, x2, y2 turns out to be 0, 1. Now that we've done x2, y2, let's move on to x3, y4. So look at these 2 points. What's smaller, 8 or 4? Well, whatever's smallest goes in x3, y4. So you should have put 4, 3. Now there's only one dot left. Notice, as we were working through these, we marked them out, that we're just organizing our work. You can never be too organized in your math. So let's go ahead and put in our last dot, which was 8, 7. So we use tables because we want to figure out if a function is linear. So what is a linear function? Well, a linear function is a rule that makes a straight line when you graph it. Remember, these ordered pairs, these relations, are dots on a graph. So when you plot your dots or your points and you connect them, like what we see here, and it forms a straight line, we call it linear. See, L-I-N-E, line. That's where we get linear from. And this is what we call, it has what we call a constant rate of change, which you're going to learn is slope. And later on, next lesson or two, we're going to use this equation. This equation is going to show up for the rest of your mathematical career, but it's pretty easy. All this means is your output, y, is equal to your slope times your input, which is your x, your your domain plus your y-intercept. That's just where it crosses the y-axis. This is all pretty easy. You don't need to know this for this lesson. It's just foreshadowing for the next lesson to let you know everything we do here today has a purpose. Here's some real math. We're going to work with tables. And we're going to work in tables for the rest of this course. Our question here is this linear? Well, step one is we put these points in the table. So you figure out what x1 is, you put it in the x1, y1 spot. You figure out what x2 is, you put it in your x2, y2 spot. Same thing with x3, y3, x4, y4. And remember, x sub 1 or x1 is your smallest x value. So look for x with the smallest number, put it here, and then put its y partner here. You may want to go ahead and pause the video as you work on that, and I'll be on the next slide with the right answer and some more explanation. Here's my completed table. I have in x1, y1, I've got 0, 1. x2, y2, I have 2, 4. And x3, y3, I have 4, 7. And then finally for x4, y4, I've got 10. So just take a moment, double check your work, and then we'll move on to step 2. Now that we've got the table properly filled out, let's look at our x values. You've got 0, 2, 4, 6. So what I notice is there are no repeats. What do we know about relations with x's that don't repeat? So we know our x's don't repeat, so there's no repeats. And a second ago I asked you, what do we know about that? Well, when the x's don't repeat, we know it's a function. So now we want to know if it's linear. And here's a good spot to mention, like we basically got 3 questions. 1, is it linear? 2, is it non-linear, which means is it not a straight line? Or your third option, it's not a function. So later on, you'll be given some problems. You'll say, this relation, is it a function or is it not a function? Is it linear or is it non-linear? To determine if a relation is linear, what we want to do is we want to look at the changes. So we're going to start by looking at the changes in x. It's right here. So from 0 to 2, well, you go up by 2. 2 to 4, you go up by 2. And then 4 to 6, you go up by 2. Since it's at plus 2 each time, we say this is a constant rate of change. Next, we want to look at the changes in the y value. So think about from 1 to 4, 4 to 7, 7 to 10. Think about it for a second, and I'll show you what I think it is in just a minute. You may want to pause the video as you think about it, but how do you get from 1 to 4? How do you get from 4 to 7? And lastly, how do you get from 7 to 10? Did you say add? Well, if you did, you're right, because 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. Since you have plus 3 each time, once again, that is a constant rate of change. Up here we have a constant rate of change. So if you have a constant rate of change with the x's, which we do, and y's, it is linear. And for it to be a straight line, you have to have a constant rate of change among the x's and y's. If you have a constant rate of change in one location but not the other, it's not a straight line. Okay, next one here, we're going to keep working with tables. Is this relation linear? We're going to do the same thing that we did before. So you need to plot your points, x1, y1, x2, y2, x3, y3, x4, y4. Do you remember how to figure out your x1? That's right, x1 is always your smallest x coordinate or value, right? So I'll let you look for that on your own, and I'll meet you on the next slide with this table properly filled out, and then we'll work through the rest of this example together. And here's what your table should look like. I'm just going to double check my work because I like to be thorough. That's x1, y1, that's in the right spots. x2, y2 is in the correct spot. And then we got x3, y3 in the correct spot. I'm going to mark everything off I've worked with. So you got x4, y4 in the correct spot. So we've got that. That checks out. Is it a function? Well, the x's do not repeat. So yes, it's a function because all of my x's are unique. And then finally, what is the pattern? Well, to go from 1 to 2, you got two options. You can do 1 plus 1. That equals 2. So that would work. Let's see what happens if we add 2 and 1. 2 plus 1 is 3. Well, 3 is not 4, so 3 does not equal 4, so that's not the right pattern. So let's try something else. What's another way to go from 1 to 2? That's right, multiplication. So if you do 1 times 2, well, that's 2. And then 2 times 2 is 4, and 4 times 2 is 8. So we know our x pattern is times 2. Kind of clean this up here because I like my work to be as neat as possible. So times 2. Now, we know it's, at this point, we know it's a function, and we know it's non-linear. The reason it's non-linear is because our rate of change is times 2. For it to be a straight line, you have to have a constant rate of change with addition or subtraction. But let's go ahead and finish this out. To get from 1 to -3, well, you can multiply by -3, because 1 times -3 is -3. -3 times -3 is a positive 9. And 9 times -3, well, that's a -27. So the pattern, so the x pattern is times 2, y pattern is times 3. It is nonlinear because our rate of change is with multiplication. For it to be a straight line, you have to have a constant rate of change with addition and subtraction. Since we're having fun with examples, here's one more. This is going to work just like everything else we've done. So we're going to put our ordered pairs in the table, x1, x2, y2, x3, y3. So people are like, why is he always doing that? Well, because repetition is the key to learning, especially in mathematics. It's all about practice and repetition. So first step is you need to place the ordered pair into the table. We'll pause the video, or you should pause the video, and I'll be on the next slide waiting for you. Okay, once you plotted your points, they should look like this. This one's a little bit different because we had a negative number, and there's not another x that's smaller than -4. So in our x1, y1 position, we got the ordered pair -4, 3. Then we have 0, 12, and x2, y2, and then x3 is 4, y3 is 4, and the only thing left is x4 for 8 and y4 for -3. Is it a function? Let's see. I do not see any repeating x's, so it is a function. Now, what's the pattern? Well, let's look here. You may want to pause the video and figure it out on your own. Well, to go from -4 to 0, you add 4. To go from 0 to 4, you add 4. Then you go from 4 to 8, and you add 4. So we know this is constant. It's constant by 4. Let's look at the y now. To go from -3 to -4, you can either plus 15 or multiply by -4. Well, see, how do you go from 12 to 1? Well, you can only subtract 11. And then to get from 1 to -3, you can either subtract 4 or multiply by -3. So there's no pattern for the y. There is no pattern, or no apparent pattern. There may be a pattern, but I don't see it. So there's no apparent pattern. There's nothing we can do with Algebra 1 to solve this. So the pattern is x's, add 4, y, see, no pattern. You just say no pattern. If you want to be more grammatically correct, you can say no apparent pattern. So it is a function. And if there's no, even though the y's is plus 4, since the y's have no pattern, it is non-linear. Because in order for it to be linear, you have to have a constant rate of change with the x's through addition or subtraction, and you have to have a constant rate of change in the y's through addition or subtraction. And since we only have one constant rate of change, it is nonlinear. Here's our last example, and it's a non-function example. I just feel like it's important to discuss this because it's going to be on your independent practice. So we went ahead and we placed our points here. -4, 0, 8, 8. So is it a function? What do you think? What do you think about that? Is it a function? No, it's not, because, and the reason, and sometimes your task would like, explain why it's not a function. Well, you say it is not a function because when x is equal to 8, y is equal to 1 or -3. So you have multiple outputs for the same input. Okay, here's what we learned today. First, we learned patterns are things that repeat. If it repeats, it's a pattern. A sequence is a mathematical pattern because it has numbers. So anything with numbers or values that repeats, and this could include expressions or equations because those are numbers, but any pattern with number is a sequence. A linear function is a It's a relation that has a constant rate of change with both the x and y values, and that constant rate of change is found with addition and subtraction. If it's constant with multiplication or division, it is not linear, it's geometric. And there's, at this point in the course, there's two types of functions. There's linear or nonlinear. And if a function is not a function, state, well, it's not a function. Just remember, when analyzing relation, always check to see if it's a function first, and then determine if it's linear. So if it's a test question and it says, is this function linear or nonlinear? Well, first check to see if it's a function. If it's a function, you'll say not a function. You can save yourself some work. And then you look for a constant rate of change through addition and subtraction among the x values. And then you look for a constant rate of change through the y values. So now you should know enough to practice.